This is Honors Geometry Lesson 10.3, Properties of Chords. So there are a few rules about chords I'd like to talk about. The first one says that if you have congruent chords, then you have congruent arcs. So if we look at the first example, they're showing us that the chords are congruent, and therefore we can assume that the arcs are congruent. So in this one, I can assume that if this is 75 degrees, this is also 75 degrees, and we know that the measure of an arc is equal to its central angle, so I'm going to say that that's 75 degrees. On this one, they're showing us that the chords are congruent by telling us they both are 34 units, so we're going to take 360 minus the 128. We know a full circle is 360. Subtract the 128. Get 232, and then we're going to divide that by 2 because we know that these two arcs are congruent, and we see that each of these arcs is 116 degrees. Okay, this one is the next theorem we're going to look at. Let's take a look at that. We have a couple more. The first one says that if you have the diameter of the circle and it's perpendicular to your chord, then it bisects your chord. And then the converse of that is also true. So let's look at what that's talking about. We can see we have a radius or a diameter. We can see it's perpendicular to our chord, therefore we can assume it bisects that chord. And if we saw that the chord was bisected, we can assume that the radius or the diameter is perpendicular. The last rule I want to talk about, it says if two chords are equidistant from the center of the circle, then we can assume those two chords are congruent, and the converse is also true. If we have two congruent chords, we can assume that they're equidistant from the center of the circle. A couple things important here. They're showing you that they're equidistant, and it's important that you see this right angle. That right angle tells us that they're measuring straight, okay? So if we would go at a different angle, we wouldn't be able to tell that they are congruent. Okay, so the first one here, I lost my radius somehow. They're showing us that it's the radius, it's coming at a 90-degree angle, so therefore we can assume that these two are congruent. We're going to set them equal to each other. Same thing here, you can see it's coming from the center of the circle, it's perpendicular, so we're going to set those equal to each other. This one, instead of giving us the right angle symbol, they just told us the arc is 90 degrees, therefore we can assume that that's also 90 degrees. Here's the one that says if they come the same distance from the center of the circle, we can assume that those two are congruent. Again, they have the marks here, they have the right angle symbols, so we know that we can set these two equal to each other. This one, they chose to tell us they're both 6 units, so again, we'd set those two equal to each other. And this one, they're telling us the converse, the chords are congruent, therefore we can assume they're the same distance from the center of the circle. Okay, I wanted to get to some better problems. All right, so here we go again. Here's our radius to a chord. It's perpendicular, so I can assume that these two are congruent. We know that all radii are congruent, so if this is 14 units, I can assume this is 14 units. I can assume this is 14 units. So if this is x, I can carry the x over here. So you can see we have a right triangle where we're missing one of the legs. So I'm just going to use good old Pythagorean theorem. X squared plus 9 squared equals 14 squared. I'm going to take 14 squared, subtract 9 squared. I get 115. Square root both sides. And I can see that's about 10.7. And we knew it was going to be less than 14, so that seems like a reasonable answer. Let's look at one more time. This time they're telling us that the diameter is 36.2 units. So the first thing I'm going to do is just split that in half. So it looks like each of my radii are going to be 18.1. So I know this is 18.1, 18.1, and this is also 18.1. Then we can see that we have a radius to a chord and it's perpendicular. So I can assume that I can carry this 13.9 up here. So what we're going to do, we're going to do good old Pythagorean theorem, because again we have a right triangle. I want to see how big this piece is. And the question is, how big is this piece? So once I figure out how big this leg is, I'm going to take the whole length of the radius, which is 18.1, subtract this piece, and we'll have our answer. So again, the first thing we're going to start with is Pythagorean theorem. I'm going to say that 13.9 squared plus b squared, we'll call it, equals 18.1 squared. So I'm going to take 18.1 minus 13.9. 18.1 squared minus 13.9 squared, and that gives us 134.4. And then we're going to square root that, and it looks like we're looking at about 11.6. So I'm going to put the 11.6 here. That was our missing side. And then again, I can assume that this radius is 18.1. I take 18.1 minus 11.6. And I get our missing little piece here is 6.5 units. Okay? Because this was a fairly short lesson, I included a review starting back at the beginning of circles. Some of the problems are going to be challenging, but I would start by saying, what can I assume? Mark all your radii congruent. Mark a radius to a tangent as perpendicular. If two segments come from an external point, they're going to be congruent. So mark everything you can assume and then go from there. Look for your 180s and triangles. Please email me if you have any questions, and have a good day.